this tutorial, I will be showing you how to find the critical amplitude with the MFP 3D. My reference materials for this video are these two journal papers. 1. By Stability of Amplitude Modulation AFM in the Air, Deterministic and Stochastic Outcomes for Imaging Biomolecular Systems. By Sergio Santos et al. And 2. Effective AFM Cantilever Tip Size, Methods for Insider Determination. By Carlo Maragliano et al. I would like to mention that these video series is based on amplitude modulation AFM. In amplitude modulation, AFM, the cantilever is oscillated at a fixed frequency, usually at its natural frequency, while the oscillation amplitude is used as a feedback parameter to recover the sample topography. This fact was detailed in our previous video. Two force regimes might occur depending on the tip-sample interaction. The cantilever is in the repulsive regime when intermittent mechanical contact between the tip and sample prevails, while it is in the attractive regime, when the tip-sample interaction mainly involves non-contact. A major feature of AFM is the presence of bistability, which involves sharp stochastic transitions from attractive to repulsive regimes. In APD curves, the amplitude, phase lag, and deflection are recorded. When the phase of a free oscillating cantilever lies above 90, the average force is attractive regime, and when it lies below 90, the average force is repulsive regime. For small free amplitudes, the attractive regime prevails for all perturbed amplitudes. As the amplitude is increased, there is a range of values of free amplitudes for which bistability is observed. This can be seen as an abrupt jump from the attractive to the repulsive regime. This interval of free amplitudes is defined as the range of critical amplitude. The critical amplitude is the minimum value of free amplitude required to transit from the attractive to the repulsive regime at resonance. The magnitude of the chosen free amplitude determines the regime. So to image in the attractive regime, set the free amplitude below the critical amplitude, usually about half of the critical amplitude. To image in the repulsive regime, increase the free amplitude above the critical amplitude. In this case, you can double the value of the critical amplitude. I will demonstrate how to determine the critical amplitude using the MFP 3D. To find the critical amplitude, we need to do a forced plot rather than imaging. Force plot is used to find the binding forces between the tip and the sample, while imaging is used to determine the topography of the sample. So let's get started. First, calibrate the AFM as discussed in the previous video. After the tip approach, click on the master panel and click on the force tab here. For convenience, click on the force panel tab here to separate the force panel from the master panel. Next is to reduce the cantilever amplitude to about 100 mV and set point to 80 mV. Click on the Engage button. And now set the force distance to about 30 nanometers. This value can be tuned depending on the probe to observe the whole range of perturbed amplitudes and phases. The force distance is how long the force distance cycle will be, provided a trigger point is not arrived at before that. The trigger point is defined as the minimum value of amplitude that is reached before the tip is retracted while recording APD curves. Set the trigger point to 30 mV. Move the mouse to the white bar on the left of the master panel and Control-click. This help sets the start distance to be the force distance above the current Z position. Now click on the Single Force tab. This plot shows the amplitude in meters and phase in angle. I want the amplitude in volts and also the deflection on this plot. So I click on the Channel tab here and select the desired parameters. More on these parameters in the future video. From this curve, you can see that the cantilever is in the attractive regime. Bequeath the phrase is greater than 90 as shown. So I will increase the value of the free amplitude gradually by an increment of 30 mV, and I will click on the single force tab again to plot the force curve. There is still no bistability. I keep increasing it gradually and repeating the force plot. Now I see bistability around 250 mV. Now remember, bistability exists in a range of free amplitude, and the minimum amplitude it occurs is the critical amplitude. So I decrease the amplitude by, let's say, 10 mV and see if it exists. Okay, let's reduce it to 230. It still exists. Let's try 220. Is gone. So 230 is the least free amplitude I notice bistability. So the critical amplitude for the cantilever is 230 mV.